Alright, hi guys, this is a walkthrough video for the smart lighting system, and this is the ASM file that will be loaded into the bin file in the EMU8086 and then loaded into the simulation. So I set the CS as 100 just because the emulator, you'll have to manually set it if you don't do it here to get it to run smoothly. And these are just this you can copy from the template. This you don't have to do. We'll get to the variables. The R counter array basically just stores how many people have crossed the sensor before you reach the gate sensor. So I'll tell you how the logic works first. The logic of the program is written in the flowchart. So what we do is, as soon as we begin the program and the memory is initialized, the program checks the gate sensor. Basically, it will wait till the gate sensor is triggered. Now, if the gate sensor is not triggered, it will move on to checking all the other sensors that are in front of each of the rows. There are 5 rows and there's a sensor in front of each of them. So it will basically check all the sensors if any other sensor other than the gate sensor is triggered. If so, it will update that in the array that suppose the row 4 sensor is triggered. Suppose someone is leaving from row 4, the row 4 sensor will be triggered. That will be updated in the array, and then we'll go back to checking for the gate sensor. And again, the guy who got up from row 4 will go to row 3, row 2, row 1. And since till now gate sensor is not triggered, we'll keep going in this loop of checking the other sensors, and we'll keep coming going around in this loop till the gate sensor is triggered. Once the gate sensor is triggered, means if you are entering, then the array will be cleared till now. If you're exiting, then there will be some values in the array, right? So once the gate sensor is triggered, it will check the array and it will check if the row 1 value is true. Why are we only checking for the row 1 value? Because suppose you are entering, the row 1 sensor would have not been activated till now, because the first sensor to be triggered will be the gate sensor. So if the row 1 value is 0, then in the array, then you are entering, so you'll go to the entry condition. If the row 1 value is 1, that means no matter what row you got up from, you have definitely crossed the row 1 sensor to get to the gate. So now that the gate sensor is triggered, you'll check the row 1 value. If you see the row 1 value is 1, that means someone crossed that sensor. You know that someone is exiting. So you go to the exit condition. Both of these obviously loop back to the gate sensor because it's not just one person who's entering or exiting. Now this is the flowchart for the what the program does to check all the other sensors. So say the row 1 sensor is true, you make the second index of the array 1. The indexes are counted from 1 here. So the second index is counted, is made 1. Then you move on to check the other sensors and so on. After you've checked all 5 row sensors, you go back to the beginning of the loop to checking the gate sensor. Now we move on to entry condition. Let us suppose that someone is walking to the gate. The array is obviously clear till now. You walk through the gate. Now once you walk through the gate, the entry, and you check that the row 1 value in the array is false, you go to the entry condition. Now in the entry condition, you basically check for row 1 count, which in the code are stored in the seats variables. This seat array has 5 zeros right now because we're assuming the auditorium starts off empty. And as the program goes on, you'll see how this is updated. So every time someone enters, we'll check if the number of seats in row 1 are filled. We're supposing 10 seats per row. So if the row 1 count is 10, that means you can't accommodate anyone else. So it'll go to row 2, and if that is full, to row 3, and so on. If it's not full, it'll increase the row 1 count. And now we'll check if row 1 count is 1. If row 1 count after increase is 1, that means it was 0 initially, and now someone is entering the row for the first time, and we want to switch on the lights. So if it is now 1, we'll switch on the lights, and then we'll move on to clearing the arrays and going back to the running to the loop where we go back to checking the gate sensor. If it's not 1, suppose it's a high number, suppose someone was already sitting in the row, then we just skip the switching on lights part and we go to clearing the array for further use. Same goes for all the rows. All of the rows follow the same logic. We're assuming that no more than 50 people enter. We're not assuming that a 51st guy will come in and not know that the rows are not filled and walk inside. So if all four first rows are filled, that is all of their count is 10, we just increase the row 5 count, and then we go to checking if the row 5 count is 1. Now let's move on to the exit condition. In the exit condition, we're doing suppose. So how will the exit condition be triggered? So the gate sensor was triggered. I checked the array for the value if the row 1 sensor was triggered before the gate sensor was triggered, and say the row 1 sensor was triggered. That means someone got up from some row, we don't know which row yet, and they triggered the gates row 1 sensor, and then they triggered the gate sensor. Now so we're checking the max row value in the array. Now this max row value is updated in the code whenever you're checking for the sensors. So suppose now this is in the loop where we check for sensors and update the array. So say I get up from row 4. Now when I get up from row 4, the code doesn't just make the value of the row 4 index of the array 1. It also checks if the row 5 index is 1 before it. Now if the row 5 index is 0, that means the guy is actually getting up from row 4. So what it will do is it will update the array value of the, it will update the variable value of the max row to row 4. Now because the row values are updated before you get to the gate sensor, what will happen is we just know which row the guy got up from. So we can straight up decrement the row count for that row to get to find out what seat has been vacated. Now we check if the row count for this row, for the max row that we have just decremented, is now 0. Because if it's now 0, we would want to turn off the lights. If it is 0, we put the condition for turning off the lights. If it is still not 0, then we'll just skip that part and go to clearing the array for further use. Now I'll go to the code and show you how all of this is implemented. So 8255 is the part we're using for interfacing with the sensors. And in Proteus, we didn't have the sensor, so we just used switches to simulate the part that the sensor would have played. Now we're using port A for input, and we're using port C for outputs to LEDs. And the rest of the code is pretty standard. Here we initialize the ports. The RAM is set to 2000. Your addresses might be different. You want to check that. All of the variables have been set to 0. Now this is how we check for entry. So in the gate sensor. So basically this, why this specific 80 number? Because okay, so I'm using in AL comma 00, and you can see in the interface part that port A is 00H. So what we're doing is that we're checking for the input in the port A, and we're saying that basically you AND it with 80. So I only want to know the first bit, the MSB of this input, and I want to say if the MSB is 1, that means I know that the MSB corresponds to the gate sensor. So if the MSB is 1, then you jump to X7, which is the condition for entry or exit. If it's not, you go to the part of the flowchart where you just update the array for anyone who has crossed your sensors. So this is the part of the flowchart where you just check for the sensors being triggered. That means the gate has not been triggered yet. So same thing as above, we're checking for inputs and we're checking for a specific bit. Now how did these 80 and 40 specific values come about? That we see from the hardware here. So SW8 here is my gate sensor. It's actually right here, it's a switch, but in hardware this will be a sensor. So this is joined to PA7. Now PA7 will be my MSB, and I only want to check if the SW8 bit has been turned on. This is why I'm using 80, because PA7 will be turned on when this is turned on. And because we only have 6 sensors, so I have grounded the PA0 and PA1 bit. Now we come to the code again, and I'm doing the same thing like 40 for row 1 sensor. So the sensors are SW8 is gate, SW7 is row 1, and so on. So we're doing the same thing now. If the row 1 sensor is not triggered, we'll just jump to checking for the row 2 sensor, and so on. The code has a lot of comments to help you through it, but I'll still explain a lot of it. So suppose that the row 1 sensor is triggered. Now if the row 1 sensor is triggered, it won't just jump to x-ray, it'll come here, and this is a delay loop. Now I'll explain later why we've added a delay loop when I'm explaining the code, the working of the code in the simulation, but right now let's skip this. So when we get to the add r counter, so this r counter array, r counter plus 1 is basically where you are incrementing the row 1 count. So I've incremented the row 1 count by 1, and now I'm comparing the row 1 count to 0. So say the row 1 count was -1 before, you'll see why it could have been -1, and if the row 1 count was initially -1, now it will be 0, and I don't want to update the max row value in this case. I only want to update the max row value if it's 1. We'll get to why it could have been -1 later. So basically, if the row 1 count value is 1, then we check for the row 2 sensors value in the array. So I'll say compare r counter plus 2 to 0, and if they're not equal, that means if r counter plus 1 is actually 1, then we'll just go back to x. If it's not 0, then we'll go back. So if it is 0 in fact, then we'll move max row 1 to max row. Why we've done this is basically I want to know that because the row 2 value in the array was 0, the row 1 value is now 1. So I know that the person who's getting up is getting up from row 1. So max row will be updated to row 1. The same thing is applied for all the sensors ahead, and this is checking for all the sensors. Now say that the gate sensor is triggered. So this is all the x2 part. This entire indent, right indented part is the x2 part. The x7 part is the part where you have a trigger in your gate sensor. So suppose the gate sensor is triggered, you come here and you basically check the, you basically move 1 to the r counter 0th index, which basically means that the gate has been triggered, and you compare the row 1 value, r counter plus 1, to 1. So if it is 1, that means someone is exiting. If it is 0, someone is entering. This I have explained from the flowchart. So y1 is the part where someone is exiting, and z1 is the part where someone is entering. So let us assume that someone is entering. The row 1 count was 0 in the array, and the array is till now all clear except the gate count that we just incremented. So this is the part of the array where we check if the seat count is full. So we're basically checking if the seats array 0th index is row 1. So if the seats array's first value is 10, that means this row 1 is full. So you can't sit there. Same goes for row 2, row 3, and row 4. Now again, I told you that we don't check for full being full in row 5 because we assume that no more than 50 people enter the auditorium, and so we just get here. Now suppose that the row 1 count was not full. So what do? So we basically want the person to sit in row 1. We're assuming the rows fill like orderly. So the person entering sits in the row that has a vacant seat that is closest to him. So row 2 will not fill till the time there is a vacant seat in row 1. That is the underlying assumption in this code. Z2 we'll see here. What it does is, so basically I have sub r counter plus 1. This is the array value, the sensor array that we made earlier. This is the same array. So I have decreased the first index, the row 1 sensor value, by 1. Now this is what I told you earlier about that the value could have been -1. Why I have done this is, so this is suppose you are entering, and because the so you enter through the gate, and I calculate that you're about to sit in row 4. Now after this you'll pass through the gate sensor, and the gate sensor will be off. When the gate sensor is off, it'll go through the updating value of the loop of the array. So basically you'll just check all the sensors and update the array accordingly. So what's happening here is that basically because you entered through the gate and you have to go to row 4, you'll also be triggering row 1, row 2, row 3, and row 4 on your way to row 4. So I don't want the array to reflect this change. I don't want the array to say that yes, this person has triggered this and there is a change that this array is now 1, because 1 is reserved for conditions where people are exiting. So what I did was I made the
array value is -1. So so basically row 1 count is now -1. Row 1's value in the array is -1. Row 2's value in the array is -1. Row 3's value in the array is -1, and same for row 4. So now by the time you walk to row 4, as soon as you trigger the row 1 counter, it'll increment by 1, and hence it'll make it 0. Same goes for row 2, row 3, and row 4. So by the time you reach to the seat you were designated at the gate, so the gate knows where you have to sit. So by the time you reach your seat, the array is actually now on all zeros. So suppose now someone gets up from row 3 and starts to leave after you sat down, so this won't create a mess up in the array, because the array has actually been reset to the point that everything else is now 0. This is why we sub r counter plus 1 to 1. So basically I have decremented the row 1 counter by 1, made it -1, and I have add seats 1. So this is basically I have incremented the number of people sitting in row 1 by 1. Now I'm comparing the seats to 0. So what I'm doing is basically I'm saying that if the count of number of people sitting in that row is greater than 0, so basically just this is the part where you switch on the lights. This entire code that has been selected is the part where I switch on the lights. So L status is the variable that stores the current condition of light. So basically it stores which lights are currently on. And now I move it to L. I move BL1 basically 80 in hex. Why 80? Because again this is related to the hardware, how I've like wired it. So PC7 is my row 1. This is the part that's already glowing is row 1. So this is connected to PC7. Now what I want is this only row 1 to glow. So what I'm doing is I'm basically saying that 80. So I just want this bit to be turned on more. So I am or AL comma BL. So whatever the values were other than the first bit, I don't care about them. I only want the first bit to be turned on irrespective of its previous value. And then out 04H comma L. Again, if you remember how we interfaced it, 04 was the port C equivalent. So I have made basically port C is my output port. It interfaces with the LEDs. So I have made the first row lights glow out 04H comma L, and then I have updated the status of the lights in the L status variable. And then C2 is the clear array part. So yeah, I'll show you that. So it basically makes the gate part of the R counter array 0, and it makes the max row variable also 0. This again is the delay part. I'll tell you about this when we get to the working of the code. Now the same follows for all the rows, and comments tell you why everything is done. Now let's get to the exit sequence. So suppose you're not entering. Suppose when the gate sensor is triggered, you see that the row 1 sensor array value is also 1. So someone was leaving, hence they have triggered row 1 sensor before getting to the gate sensor. So what do you do now? So you basically, because we update max row while actually updating all the array values for the sensors, so we can just compare the max row value, and given the value of the max row variable, if it's 1, that means someone is leaving from row 1. So seats is basically the array that stores how many people are sitting, and so I basically just subtract 1% from the number of people sitting in row 1, and now I compare it to 0. If it's not 0, I just skip to clearing the array. If it is 0, I will want to turn off the lights. Now this part again is the turning off of the lights. You can see that only the first bit is 0, and I am ANDing the current status of the lights with this 011111 bit value. So what this will do is, irrespective of what the other values of the status of lights was, I only want the first bit of this thing to be turned off now, to be 0 now. Again, to turn off the lights for the row 1, as I've shown you in the hardware in the Proteus simulation. And we move to C1. The same thing is done for all the exit conditions. C1 again is this C1 is full clear. So C1 basically clears all the values in the array and the max row value. Why I didn't clear all the values during entry and only I've done it during exit is because during entry I have made some values of the array -1. Now if I clear them, they will become 0, and when you walk through the sensors, they'll become 1. I don't want that happening. I want those values to remain -1, so that when you walk through the sensors and the array gets updated, it gets updated to 0, not to 1. Again, there's a delay loop. So basically, I moved some count to CX, and I have performed NOP is no operation. So basically, this does nothing except waste time, and it's necessary to waste time, and I'll show you why when we run the code. So that's it about the flow of things. There's no assumption on when you exit. You can leave at any time. There's no assumption on how long you can enter for also, although that is mentioned in the question. But we didn't need it, so we didn't put that. So I've already loaded the file into the Proteus simulation, and I'll be running it now. I'll basically make 11 people enter, and I'll then make one person leave to show you that the thing works perfectly. And I'll make two people leave so that you can see that it doesn't just switch off the light when someone leaves from some room. Okay, we'll get started. The code is already bin file is already loaded in the microprocessor, so I'm just gonna start the simulation. You see that LEDs have been reset. I'm only zoomed in on the first two rows because this is row 1 basically, and this is row 2, and we won't be going further than that. So right now all the inputs are off. Now I'll turn on the gate input. So you can see that as soon as I turned on the gate input, the first row's lights have been turned on. This is because at the gate itself, we have calculated that the person will be sitting in row 1 and we have switched on the lights. Now, if you remember the code, the array value for R1 sensor will be -1 because I basically want it to be 0 when I cross the row 1 sensor. So I'll make him go sit in the row 1. And now I'll tell you why we added the delay. So say there was no delay in the entry condition. Now what would happen is, because the processor runs at like a very high number of operations per second, imagine your own CPU, it runs at very high number of operations per second. As soon as I switch on this switch, it basically runs it's basically running on an infinite loop. The whole code is running on an infinite loop. So it'll count once, and then it won't stop on counting the number of people once. It'll just keep counting. So the count won't go to from 0 to 1. The count will go from 0 to something like 100,000. And we don't want that happening, because at that point all the lights of all the rows will be switched on, and we don't want that happening. So that's why I've added delay. Same thing will also be for everywhere that I have added delay. It's basically to avoid the counter reaching a value that I don't want. I only wanted to increment by 1 or decrement by 1, whatever.
Now, right now, as you can see, I have just fast forward through adding like 11 people. Now, you might have seen that the PB0 lights lit up between, and all of them lit up. That was because I have made a condition where PB0 indicates the row 2 value, sensor value of the array. So, as soon as I switched on the gate, and some person was supposed to enter row 2, as soon as I switched on the gate for the 11th person, the program calculated that he was supposed to enter row 2, and because the program calculated that he was supposed to enter row 2, the array value of row 1 sensor and row 2 sensor were both made -1, and -1 is FF for row 2. So the array value was shown in PB0. This is just added as a failsafe to see if the code works correctly, and it shows on PB as output, and all of the lights glow. As soon as I turned on the PB sensor, it went back to 0 as it should have. Okay, I've reset the simulation to show you the exit part. I'll make one person enter, and see the lights glue because he's about to sit in row 1. Now, this was us making him sit in row 1. Then let's make this person leave. So say someone crosses the row 1 sensor again. That means that person is about to leave. When he comes through the gate, it should decrement the row 1 count and the lights should turn off. As it did, the row 1 count is now 0. And that's how it works for all the rows. And you can check. Keep in mind the delay that has been added. So between two switch presses, between two sensors, there's a delay of about a second and a half. So keep that in mind. Okay. Thank you guys.